Hello and welcome to A-Level Math. This is the third video in the series Circles. In the first two videos, we covered the equations, the form of the equations of the circles and how to find out the center and the radius of a circle given its equation. If you haven't seen my previous videos, please click on the I button above. In this video, we are going to talk about the position of a circle, the line or the point of intersection of two circles, or maybe the chords or any other tangent passing through the intersection of those two circles. Then we will discuss touching circles. So here we will be discussing the equation of tangent passing through the two touching circles. And finally, we will discuss about the x and the y intercepts of a circle. So let's get started. The equation of the incircle of an equilateral triangle is this. We need to find out its area. So let's first of all draw the diagram. So let's assume that this is our required equilateral triangle. And this is our circle with the equation 2x squared plus 2y squared plus 3x minus y minus 5 is equal to 0. So this is that circle. Now we need to find out the area of the equilateral triangle, and we are given the equation of the circle. So let's first of all try to figure out what will be the radius of this circle. So to find out the radius, what we know is that we have the equation already. So let us write it down. 2x squared plus 2y squared plus 3x minus y minus 5 is equal to 0. And you know that we need to express this equation in its standard form, means that we need to free up the coefficients of x square and y square. So we need to divide each and every term by 2. So we get x squared plus y squared plus 3 by 2x minus y by 2 or 1 by 2y minus 5 by 2 is equal to 0. So this is what we get on dividing each term by 2. So this represents 2gx, remember, and this represents 2fy. So we need to find out the values of g, f, and this is c. And then our radius will be under root g squared plus f squared minus c. Let me write down the formula once here for you. So the formula is root over g squared plus f squared minus c, where g and f we need to figure out what they are. So we know that 2gx is the term with this. So let me not write this x. So 2g is actually 3 by 2. So g is equal to 3 by 4. Also 2f is equal to minus 1 by 2. So f is equal to minus 1 by 4. And c is equal to minus 5 by 2. So we need to figure out what is r. R is root over g square, which is 9 by 16, plus f squared, which is 1 by 16, minus c becomes plus 5 by 2, which gives us 9 plus 1, 10 by 16, plus let me multiply each and every term of 5 by 2. I mean the numerator and the denominator of this 5 by 2 by 8. So I'll be getting 40 by 16. So I get root over 50 by 16, which is root 50 by 4. So this is the radius of the circle. So let me erase all of the stuffs over here and let's just keep the radius. So what I have is the radius of the circle is root 50 divided by 4. Now what to do next? We need to find out the area of the circle. You know that this triangle is given to be an equilateral triangle, and we know that there is a relationship between the center of the circle and the equilateral angle. So the equilateral angle and its incircle, and if you consider the center, then the relation is that suppose if this is the radius and if this is the height of the equilateral triangle, then the relationship is that it divides this point, divides this height in the ratio 2:1. Okay, so let's assume that our entire height be h units. So we know that this radius is 1/3 of the entire height, because it divides this point, divides the height in the ratio 2:1. That means if you assume this entire height to be 3 units, then the radius is 1 unit. That means the radius is 1/3 of the height. So let me write it down over here. We know that radius is equal to 1/3 of the height. Okay, this we already know. So we get that h is equal to 3 times the radius. And if we assume the side of the equilateral triangle to be a, then we also know that the height of the equilateral triangle is √3/2a. This, I think you all know this from your secondary mathematics. So this height is actually nothing but √3/2 times a, where a is the side of the equilateral triangle. So if we consider this part, we have a relationship between a and r. So what we need to find out, is the area of this equilateral triangle. And we know that the area of the equilateral triangle is actually given by √3/4 a square. This is what we need to find out. This is the area of an equilateral triangle in terms of its side. So all we need to do is just find out the value of √3/4 a square. So let's expand this thing, square both sides. So what do we get? 9r square is equal to 3/4 a square. But what we need √3/4a square. So 4 we already have. Let's bring this 3 on the left hand side. So if I bring this 3 on the the left hand side, and if I bring in √3 on both the sides, then I have got the value of √3/4 a square. I just need to simplify this bit and put down the value of r, which I already have from here. Okay, so let's simplify. If I cancel these out, I'll be having, okay, it's better that if I cancel this 3 with 9. So 3 times 3 is 9. So I have 3√3 r square is equal to the area which we are interested in. And on putting the value of r, I get 3√3 times r square, which is 50/16. So it's 50 divided by 16. If I cancel this, I get 225 and then 8. So I get 75√3 divided by 8 square units as the area of my equilateral triangle. And we are done. Let's move on to the next question. Find the equation of the circle passing through the point of intersection of these two circles. So we are given two circles, and we need to find out the equation of a third circle which passes through the intersection of these two circles and having its center on this line. So the question says that suppose you have two circles and they are intersecting somewhere, and then you need to find out the equation of a third circle which passes through these 2 points. So there are actually infinitely many circles which can pass through these 2 points. One can be like this or one can be like this. There can be infinitely many such circles, but you need to find out that circle that has its center on this line, x plus y is equal to 0. Okay, so remember we discussed about a similar concept in straight lines. We figured out that if you want to find out the equation of another straight line but that passes through two given straight lines, we just add those two equations with a constant in somewhere. So let me remind you that bit. Suppose I give you two straight lines, a1x plus b1y plus c1 is equal to 0. This is our first straight line. And suppose this is our second straight line, a2x plus b2y plus c2 is equal to 0. Then all of the straight lines that pass through the intersection of these two straight lines are a1x plus b1y plus c1 plus k times the second equation, a2x plus b2y plus c2 is equal to 0. So similar concept also applies over here. If we need to find out a circle that passes through the intersection of these two circles, what I need to do is just this equation plus k times this equation. That will give me all of the circles, all of the infinitely many circles. So if you keep on changing the values of k, you will be getting different circles. So that is the general equation. And then we can find out the value of k using this particular case. So we will be using the fact that our required circle, that center of that circle should be on this line x plus y is equal to 0. So let's quickly start solving the problem. So let's assume that the equation of a required circle is x squared plus y squared minus x plus 7y is equal to minus 3 plus k times x squared plus y squared minus 5x minus y plus 1 is equal to 0. So as I said, this is the equation, the general equation of all those circles which passes through the intersection of these two circles. Okay, you keep on changing the values of k, you will be getting different and different circles. But we need to figure out one particular circle given this condition that its center should lie on this line. So let's quickly find out the center of this circles. Okay, so for that, let me take all the x square and y square together. So if you see, this is x square plus y square, and this is also x square plus y square. If I take x square plus y square common, I get 1 plus k. So if you take x square plus y square common, 1 is left over here and k is left from here. And then what else remains? So let's take x common. So if you take x common, so plus x, then what remains is minus 1 here, and then minus 5k here. And then if you take y common, then what remains is 7 over here and minus k over here. And then comes the constant, which is minus 3 plus k, and finally equal to 0. Now we need to reduce this into our standard form. That means we need to free up the coefficients of x squared plus y squared. So for that purpose, I divide each of these terms with 1 plus k. So if I divide 1 plus k over here, it vanishes. So 1 plus k will not be there, and each and every term will have 1 plus k in its denominator. So if I push this minus over here and put a plus over here, then yeah. Or we can better write it as k minus 3. It will look good. So k minus 3 by 1 plus k. So okay, now we know that we need to find out its center. So for the center, I know that my center is given by minus g comma minus f, and this part represents 2g and this part represents 2f. Right? So what will be my g? G will be this thing divided by 2. So my center is minus g comma minus f, which is negative of this divided by 2. So negative of this divided by 2 means all the signs will be changed over here. Okay, let me do it in a better way for you. So I know that 2g is equal to minus 1 minus 5k by 1 plus k. I need to figure out the value of minus g from here. So first of all, I divide by 2. So 2 goes here and then minus. So all of these become plus. So the value of minus g becomes 1 plus 5k divided by 2 times 1 plus k. And similarly, to find out the value of minus f, what I need to do, divide this by 2 and then change the sign. So change the sign means 7 minus k will become k minus 7 divided by 2 times 1 plus k or k plus 1, whatever. Let me write it down as 1 plus k only for consistency. So this is the value of my minus f, and this becomes the center. Now the question says that this center lies on this line. That means it should satisfy this equation. So I just put down the values of, put these things in place of x and y. So I get 1 plus 5k divided by 2 plus 2k plus k minus 7 divided by 2 plus 2k is equal to 0. And on simplification, what I get is 1 plus 5k plus k minus 7. So 5k plus k gives me 6k, and 1 minus 7 gives me minus 6 divided by 2 times 2 plus 2k is equal to 0. So cross multiplying vanishes this thing. So all I'm left with is 6k minus 6 is equal to 0, or 6k is equal to 6, or k is equal to 1. So I've got the value of k. I just need to plug it down inside here and simplify to find out the answer. I leave this to you as an exercise to complete and solve. Next, show that the circles x squared plus y squared plus something something and something touch each other externally. Okay, so they are giving us two circles, rather the equation of two circles, and they want us to prove that they are touching each other externally. So that we need to prove they just touch each other externally. This is what we are required to prove. So assume that these are the two centers of the circle, and this is the radius of the first circle and this is the radius of the second circle. Now if these two circles touch each other externally, this means that the distance between the centers of the two circles, so the distance from here to here, which is the distance between the two centers, is actually the total distance. It's actually just the sum of the radius. So this radius, the radius of the first circle plus the radius of the second circle. Okay, so let me tell you once more. If two circles touch each other externally, then the distance between their centers is the sum of their radii. So let's quickly find out the centers and the radii of the two circles. So let's consider this circle first. So the center is given by minus g minus f. So divide by 2, change the sign, divided by 2, change the sign. Remember the thumb rule. So minus g comma minus f for the first circle gives me minus, and then 6 by 2 is 3, comma minus 14 by 2 gives me 7. So this is the center of the first circle, and the center of the second circle in a similar way will be divide by 2 and then change the sign, so 2, and similarly divide by 2 and change the sign, so 5. This is the center of the second circle. So this is the center of the first circle, this is the center of the second circle. Okay, and we need to also find out the radiuses of the two circles. Okay, so if you consider this circle, then its radius is g squared plus f squared minus c. So 3 squared plus 7 squared minus 9, this is r square, so root over will give me the radius. And similarly for the second circle, g squared plus f squared minus c will be minus 2 squared plus minus 5 squared. So because this is minus g and minus f, right? So that is why g will be minus 2 and f will be minus 5. So g square plus f square minus c, the entire thing rooted, will give me the radius of the second circle. So on simplification, I'll get the radius to be 9 plus 49 minus 9. So 9 and 9 cancel out, root over 49 is 7. So this is the radius of the second circle, sorry, the first circle. And if I simplify this, I get 4 plus 25 plus 7. 25 plus 4, 29 plus 7 is 36, root over 36 is 6. So the radius of the second circle is 6 units. All right, let me clean up all these stuffs over here. So I have written down the basics. So I mean the radius r1 of the first circle is 7 and r2 is 6. The center of the first circle is minus 3 minus 7, and the radius of the second, sorry, the center of the second circle is 2 comma 5. Now what? Find also and okay, so now first of all we need to prove that these two circles touch each other externally. And what I told you is that we need to prove that if two circles touch each other externally, then the distance between their centers, that means the distance between C1 and C2, is actually R1 plus R2. Why? Because this is the radius of the first circle and this is the radius of the second circle. So if you just add these two radius, you should be getting the distance between the two centers. So what is C1, C2? C1, C2 is root over x2 minus x1 the whole squared. So 2 plus 3 the whole squared plus y2 minus y1 the whole squared. So 5 plus 7 the whole squared. So this gives me root over 25 plus 7 plus 5, 12, 144 is equal to 169 inside root, which is equal to 30. So the distance between the centers turn out to be 13, which is also the sum of the radiuses. 7 plus 6 is also 13. So this proves that the circles touch each other externally. Now come to the second part of the question. Also find the equation of the common tangent of the two circles. Remember that we uh, understood that if we need to find out the equation of any curve that passes through the point of intersection of these two circles. So suppose these are the two circles and we need to find out another curve. So remember I told you that let's take that to be the so equation 1 plus k times equation 2. So that actually gives us all the circles, and also it can give you straight lines on some certain conditions. So let me explain a bit more to you. So if I take this equation plus k times this second equation, let me write it down for you first, and then I'll explain. X square plus y square plus 6x plus 14y plus 9 plus k times x square plus y square minus 4x minus 10y minus 7 is equal to 0. So this equation gives me all those circles which passes through the intersection of those two circles, and also it can give me the equation of tangent, provided that this x square plus y square term should not be there. Okay, so first of all let me again take x square plus y square common. So if I take x square plus y square common, what I get is 1 plus k, and then if I take x common, what I get is 6 minus 4k, and then if I take y common, I get 14 minus 10k, and then plus 9 minus 7k is equal to 0. Now if I want this equation to represent a straight line instead of a circle, then it means that it should be only linear. There should be only x and y and constant terms. There should not be any x square plus y square term in there. That is why I set this 1 plus k to be equal to 0, so that this equation represents a straight line which will be effectively the tangent, the common tangent of these two circles. So this gives me k is equal to -1, and if you just plug in the value of k is equal to -1 over here, you will see that it reduces to a linear equation which will give you the equation to the common tangent of the two circles. Next question, and hopefully the final question as well. Show that the two circles x squared plus y squared plus something something and this will touch each other if f dash g is equal to g dash f. Now one thing to notice in this question is that it just tells you that the circles touch each other. It doesn't mention whether the circles touch each other externally or internally. So if we know that if two circles, if we know that if two circles touch each other externally, then the distance between their centers is the sum of their radius. In a similar way, if two circles touch each other internally, then the distance between their centers is the difference of their radius. So in order to find out the distance between the centers, you just need to do r1 minus r2 or r2 minus r1, whichever is bigger. So bigger minus smaller, bigger radius minus smaller radius will give you the distance between the two centers. So now this doesn't mention, the question doesn't mention whether the touching is external or internal in this case. So what do we do then? Okay, first quickly find out the centers and the radius of the two circles. So for the first circle, my center is minus g comma minus f itself, because it is already in the standard form except for the constant term. And the radius is actually g square plus f square rooted, because there is no minus c over here. The c term is 0, so minus 0 I can safely ignore that c. And for the second circle, my center is minus g dash, so minus g dash comma minus f dash, and the radius is root over g dash square plus f dash square. Okay, and these are the two centers. This is the center 1 and this is the center 2, and these are the radiuses. Now we need to prove that if these two circles touch each other, whether externally or internally, I don't know, but whatever is the case, this should be true. F dash g plus g dash f, f dash g is equal to g dash f. If the two circles touch each other, then this thing holds. So we need to prove this. Okay, so we know that the distance between the centers is what? The distance between the centers is x2 minus x1. So g minus g dash the whole squared plus y2 minus y1. So f minus f dashed the whole squared, the root of this thing. This is the distance between the centers. So we know that the distance between the center is either the sum of the radiuses or the difference of the radiuses. So assuming that this radius is bigger than this radius, you can assume that it doesn't matter because we are going to square it anyway in the next step. So either this is equal to, the distance between the center is either equal to the sum of the radius or the difference of the radius. So either it is equal to root over g square plus f square plus g dash square plus f dash square. Either it's equal to the sum of the radius or the difference. So either it can be plus or minus. Now what I do, I square both sides. So if I square both sides, so the root over on the left side disappears and on the right side I have a square. Let's open up the squares over here. So I have g square plus g dash square minus 2g dash plus f square plus f dash square minus 2f dash gives me, if I open the squares over here as well, I get a square, which is g square plus f square, a square, then plus b square. Whether it's plus or minus, whether it's a plus b or a minus b in whole square, doesn't matter because it's always a square plus b square. The difference will be in the 2ab term. It can be either plus 2ab or minus 2ab. So here it's always plus. Okay, there is one more question after it. Okay, so let's continue. So plus g dash square plus f dash square, and then plus minus 2 root over g square plus f square into root over g dash square plus f dash square. Okay, so we observe that g square cancels, g dash square cancels, f square f dash square f square f dash square all cancels out. What we are left with is, and even 2 can be taken common and cancelled. So if we take 2 common, we get minus g dash minus f dashed is equal to plus minus 2 root over g square plus f square times root over g dash square plus f dash square, and 2 cancels out. All I need to do is just square it once more and then figure out what's happening. So I'll clear the screen. So we have negative of g dash plus f dash. I've taken a minus common over here, and then right side is as is, and then I square on both the sides. So on squaring, this minus will become plus and then square, and similarly plus minus will be removed, and on squaring these roots will be removed. So what I'll have is g square plus f square times g dash square plus f dash square. So on expanding, I get g square g dash square plus f square f dash square plus 2g dash f dash is equal to g square g dash square plus f square g dash square plus g square f dash square plus f square f dash square. So if you see g square g dash square and g square g dash square, f square f dash squared, f square f dash square cancels out, and we have 2g dash f dash is equal to f square g dash square plus g square f dash square. If I take this term on the left hand side or on the right hand side, so what I get is 0, and here I have 2g dash f dash. Now this is the square of f g dash plus g f, sorry, minus g f dashed the whole squared. Okay, and then if I do a square root on both the sides, then I get f g dash minus g f dash is equal to 0. and then transporting, I get f g dash is equal to g f dash, and we have proved the result. So see, it was a big lengthy problem with a cute little answer. Okay, how many more to go? Lot more to go. I thought it would be a short video. No problem. Find the equation of the common chord of the two circles x square plus y square something something and something something. So we are given two circles and we need to find out the equation of the common chord of the circle. So suppose these are the two circles. Now these two circles will have a common chord. So this is the common chord. We need to figure out its equation. So how to figure out the common chord is that if you understand that a chord is a straight line, right? So its equation must be a linear equation. Okay, so if I subtract these two equations, then I'll be getting a linear equation as well, and it will satisfy both of the given equations, right? But there is just one single problem in here, is that we have a 2x square and 2y square. So if we subtract, the x square and y square won't be cancelled. So what we do, we first multiply this equation by 2 throughout, or you can divide this equation by 2 throughout. So whatever you find is easier for you. So I'll just multiply this equation with 2 throughout. Okay, so I get 2x square plus 2y square minus 8x minus 4y minus 62 is equal to 0, and then 2x squared plus 2y squared minus 6x plus 8y minus 35 is equal to 0. And if I subtract these two equations, what I get is minus minus plus minus plus. So on cancelling these, I get minus 8x plus 6x gives me minus 2x, minus 4y minus 8y gives me minus 12y, and then plus 35 minus 62, I don't know, I'll have to do it. 62 minus 35. So because the negative is heavier, so minus 27 is equal to 0. And on taking minus common, I get 2x plus 12y plus 27 is equal to 0. Now this is a linear equation and it satisfies both the equations as well, because it is derived from those two equations. So it must satisfy both of the equations, and therefore it is the equation to the common chord of both of the circles. Okay, and show that this chord is perpendicular to the line joining the two centers. So half part is done. We have found out the common chord. Now what we need to do is that we need to prove that this chord is perpendicular to the line joining the centers. So let's quickly figure out what the centers are. So for the first circle, the center will be minus g comma minus f. So divide by 2 and sign changed. So 2 comma, and then divide by 2 and sign changed. So 1. 2 comma 1 is the center of the first circle, and for the second circle, remember that it's still not in the standard form. So first convert this into standard form. So in standard form, it is x square plus y square minus 3x plus 4y minus 35 by 2 is equal to 0. And now we can do divide by 2 and change the sign. So the center of the second circle is 3 by 2 comma minus 2, divide by 2 and change the sign. Okay, so these are the two centers, and we need to prove that this chord is perpendicular to the line joining the centers. Okay, so what is the slope of the line joining these two centers? If I consider this to be x1 x2 and this has y1 y2, then I know that the slope of this is y2 minus y1 by x2 minus x1, which will give me minus 3 divided by 2 times 2 is 4, 3 minus 4 is minus 1 divided by 2, minus minus cancels out, and I get 3 divided 3 times 3 by 1 by 2, which is 6. I think I've made a mistake somewhere. Where is it? No mistake, it seems. So we are good to go. So this is the slope of the line joining the center, and this is the chord, and the slope of the chord is given by, so let's write down in the form y is equal to mx plus c. So 12y is equal to minus 2x minus 27. So y is equal to minus 2 by 12x minus 27. So minus 1 by 6x minus 27. So this is the slope of the chord because y is equal to mx plus c. So this is the value of m, which gives us the slope of the chord. Now, if I need to prove that these two are perpendicular, then these two slopes, on multiplying these two slopes, I should be getting minus 1, which is indeed the case. Minus 1 by 6 times 6 gives me minus 1. So we have proved that the chord and the line joining the centers is actually perpendicular to each other, and we are done. Next, determine the positions of the points. These 3 points, we are given these 3 points, point number 1, 2 and 3, and we need to prove, and we need to find out their positions with respect to this circle. So with respect to a circle means, suppose our required circle is this. Now for these 3 points, we need to figure out whether any particular point lies inside the circle, lies on the circle, or lies outside the circle. So it's worth noting how to figure it out and what is the trick behind it. So suppose that you are given any circle and you are given a point outside it. So suppose this point is x1 comma y1. If you put down this x1 y1 in the left hand side of the circle, so you will be getting something greater than 0. If this point lies inside the circle, and if you put down then the, and then if you put down x and y, instead of x and y you put down x1 y1, you will be getting something less than 0 if it is inside the circle. And if it is on the circle, if the point is on the circle, you will be getting is equal to 0 because it will satisfy this equation. So always remember this rule of thumb, that if a point lies outside the circle, then just put down the coordinates and you will be getting greater than 0. If it lies inside the circle, put down the coordinates on the left hand side, you'll be getting something less than 0. And if it is equal to 0, it will lie on the circle. So let's quickly check for these 3 points. First of all, 1 comma minus 1. So I put down the coordinates in this left hand side. So I get 1 square plus minus 1 square minus 4 times 1 plus 6 times minus 1 plus 4, which is 1 plus 1 2 minus 4 minus 6 plus 4. So this becomes minus 4 plus 4 cancels out. I get minus 4, which is less than 0. So because this coordinate gives me left hand side to be less than 0, this lies inside of the circle. Okay. Now if I put minus 1 comma 2 instead of the coordinates, so I get minus 1 the whole squared plus 2 the whole squared minus 4 times minus 1 plus 6 times 2 plus 4, which gives me 1 plus 4 5 plus 4 plus 12 plus 4. Clearly it is something positive. We don't need to simplify it even because all the terms are positive. So this is something positive. So this point lies outside of the circle. And lastly, for minus 1 comma 3, I have minus 1 the whole squared plus 3 the whole squared minus 4 times minus 1 plus 6 times 3 plus 4, which gives me 1 plus 9 10 plus 4 plus 18 plus 4, which is equal to again positive. So this also lies outside of the circle. All right. Now let me give you an exercise. So take one more point, say for example minus 1 comma minus 3, and prove that this point lies on the circle. So what you have to do is that just plug in these values and then verify if the left hand side turns out to be equal to 0 because the point lies on the circle. Okay, so this is an exercise. Try to complete it yourself. Next and the last question. A circle touches the x-axis at 2 comma 0. I love these kind of questions because they're very much intuitive. So there is a circle. It says that it touches the x-axis. So suppose this is my x-axis. Okay. This is my x-axis. The circle touches the x-axis. And this is my y-axis. So it touches the x-axis at 2 comma 0. So this point is 2 comma 0. A circle touches the x-axis and has an intercept of 4 units on the y-axis. Okay, that means the y-axis goes through the circle and this distance is 4 units. So first of all, let me give you two important formulae and try to prove these formulae at your home yourself. So this is known as the y-intercept. All right, so suppose there is a circle, uh, these are the two coordinates. Suppose this is a circle, then this circle, if it actually cuts the y-axis at two parts, then it makes some point, it makes some intercepts on the y-axis as well as on the x-axis. So to find out those intercepts, the formula is, for the y-intercept it is 2 times root over f square minus c, and for the x-axis the x-intercept is given by 2 root over g square minus c, where f, g and c have their standard meanings. They are coming from the standard form of the equation. So to remember this formula, you always remember that g is always associated with the x term, so it's 2gx, and f is associated with the y terms, it's 2fy. So in order to find out the x-intercept, it is 2 root over g square minus c, and to find out the y-intercept, it is 2 root over f square minus c. So let's quickly solve this question and apply this formula. You are given the intercept of 4 units on the y-axis. That means this 4 units is the y-intercept. This means that 2 root over f square minus c is actually equal to 4. Okay. All we need to find out is just values of g, f, and c. So to see what happens. Now, to find out the equation of the circle, we have to use this part. The circle touches the x-axis at 2 comma 0. So if the circle touches the x-axis at 2 comma 0, and if this is the center of the circle, then this means that, so if this is my radius, so I walk 2 units in this direction, and then this is my radius. Suppose the radius is a units, so my center is actually 2 comma a. Why? Because this point is 2 comma 0, so this point is 2 comma 0 means this length is 2, and I've assumed radius to be a. So to reach this point, I move 2 units in the x-axis and a units on the y-axis. So the center is 2 comma a and my radius is a. So my equation of the circle is becomes x minus 2 the whole squared plus y minus a the whole squared is equal to a square. By the way, I have taught these things to you in the very first video of circles. If you are not comfortable, just have a quick look through the last part of the first video. We have discussed the touching circles, the circles touching the x and the y axis concept in the very first video. So let's expand this. What I get is x square minus 4x plus 4 plus y square minus 2ay plus a square is equal to a square. A square and a square cancels out. So I have x square plus y square. I'm just writing this down in the standard form. Minus 4x minus 2ay plus 4 is equal to 0. So this is my standard equation. Now this means that my g is actually corresponding to half and then change the sign. So it is 2. My f is actually equal to half and then change the sign. So it is a, and my c is actually 4. So I just plug these values of f and c over here and try to figure out the value of a, because that is the only variable we have. If we are able to find out a, we can get the equation of the circle, and if we get the equation of the circle, there is nothing else to do. We have to just find its equation. So 2 root over what is f square? It is a square minus c is 4 is equal to 4. So it's 2 over here. Squaring both sides, I get a square minus 4 is equal to 4. A square is equal to 8, and a is equal to root over 8, which is 2 root 2, but it is plus minus 2 root 2. So I get two values of a, and if I put these values of a in these equations one after the other, I'll be getting the two equations of the circles, and those two equations will be my answer. I have two answers because the position of the circle can be either on this side or on the other side. So that's why sometimes this is the logic why of the double answer, that the circle can have different positions and it should satisfy all the same constraints as well. Okay, so that is it for this video. I think there are a couple of videos more to come on the circles. Till then, study harder, study smarter with A-level math. Bye bye.